When we set this test up, we wanted to make sure that we were setting it up in as close to as field conditions as possible. When we were trying to get the boat on there, we were getting really exposed, and it was a fight to get this boat into position, and we tried and tried and tried multiple times to get it where we needed it. And then when we finally got it, now when you watch this, I know what a lot of you are going to say, hey, that's the wrong side of the boat you're pulling from. We should have been pulling from the other side. And the whole point of the test was to see what the maximum force on the boat was. So we tried to get how much strength the river was putting on it. We wanted to take the most difficult way of doing it. So we attached it to our side of the boat to see how much we can pull, and then get a little upstream angle to try and pull directly against the strongest current we were having to fight, which was the river right current.
Action.
Well, it's gonna be fun.
All right, so tell me how this setup is.
All right, we got a 3-to-1 mechanical advantage system. We got a line scale 3 here going through. All right. Another line scale back there. This way we're measuring input and we're measuring the force on the system. We've also got some heights down here.
All right, so give that a good tug, and we're gonna give this a good tug. You're at 1.57 here.
0.44.
0.44, so you got 3 times the pull force, but you're only putting on less than about 100 pounds.
Yeah.
You want to reset the thing? Oh wow, look at this. It's gone up. The water's doing more to you than you could pull. Check this out. You were putting on 1.7, 2.46 is what the water's doing. So can you get it out now?
1, 2, 3. 1, 2, 3. There it is.
Yeah.
Ooh. 1, 2, 3. 1, 2, 3.
Oh, stop.
There it is.
Your max force is 0.78, and what you're doing right now is 0.2. You're currently at 1.9. 2.5 is the water.
Watch your hands.
Yeah, I'm not getting my hands in there. All right, the prusiks are slipping because they're wet. It's currently at 2.4. So you got to do more force than you've ever done. It's not on a releasable system. Wow, we're at 3.26 right now from the water. Or that was peak force. Now it's 2.5 is the current load, and we can't put 2.5 on the system. But you didn't break a D-ring. What do you think about that? Is that normal to not break them or to break them?
Yeah, it's normal to not break them. So
okay, so that's a good thing.
That's actually pretty good. We didn't break the D-ring.
Okay, 3.26 was our peak force from the water, not from us. Not from us.
Yeah.
We could only generate 1.7-ish when...
Oh, on the hull?
On the hull, so if you you have to overcome, you'd have to overcome that. How was it for you out there?
Well, once we got the boat wrapped, I mean, it's pretty stable, not too super stressful, but the amount of force, like in that last little bit before we cut the prusik, I was trying to like lever it around, change the shape of the boat, and kind of try and pull it up and out of the water to try and get it to move. And I mean, it just goes to show that like sometimes you gotta get ropes out and move things, but as soon as we cut the rope, it did what it thought it was gonna do, and it just peeled itself out of there.
Which is the goal.
Which is the goal. It was cool to see how much water was catching when it was under tension in that last little bit where it was all on the progress capture and just hanging out.
So all of these on-river tests left us with some serious questions, and the biggest question was, how strong is a D-ring? So we headed over to Ryan's lab, and we started with a shear test on a D-ring. So that's no longer a D-ring. This definitely isn't what I expected. I mean, I expected it to tear, but I'm surprised that the material tore out here first. With all of that.
100% of the force was right here, though. because
Yeah.
we're pulling that way. If we pulled straight out, I think we'd get a very different result.
You can even see it tore there too.
Ooh.
So it actually began to tear that material
So this
out.
weld is not even a question. That's holding.
Yeah,
Over this, at least.
yeah, the real question would be pulling straight
Yeah.
from it instead. All right, so it came up, and then right over here started to drop a little bit, and then our peak was 4.47 kilonewtons, which is interesting because out on the river we had 3.5-ish on the raft itself. So we were getting close to that D-ring blowing. After we did the shear test, we wanted to know what a general strength test would be. Since the shear is going to be weaker than the general welds, we wanted to see how much it would take to pop the weld off. Well, that certainly didn't do what I expected either. I don't know what I was expecting, but
I was really hoping that D-link would break. I was so close, man.
looks like I won again.
I know.
That tore the entire urethane face off of this, and it's just down to the fabric. The urethane face is actually still on the thwart.
So the
here.
weld came out.
Yeah,
Yeah.
this tore the weld straight off of there and then ripped through 2 sheets, like 3 sheets.
What was the
fabric.
max force you got on your 3-to-1?
The max force was 4 point.
Yeah, that was just the static rope. Let's say.
Oh, that's the static
Let's
rope.
say 3 or 4, right?
So I think, yeah, I think it was like 3.5.
If you get 3
so let's
or
see.
4, and your peak force is 6, when you're not pulling in shear, but you're pulling in tension, like you're not going to break a D-link. You might actually deform it though.
So we're gonna deform the D-ring.
But you're not going to rip off the weld with a 3-to-1.
We're not gonna rip it off. I mean,
But you said you've had
Well,
it happen to you before.
I've had it happen, and so it was probably, well, this was welded, and I'm not sure if this one was heat welded or RF welded, so I have to check on that. But this is a welded D-ring, so the ones that I've had blown off were glued, and I'm interested to bring in some glued ones and see how that goes. And they're also old glue, so
Yeah.
that probably had something to do with it. But I also wonder if we tried the 3-to-1 on a larger boat, like a 16-foot raft, and we were trying to crank on that with more people. So, if we were able to get 3 on the river,
If you get 3 people pulling your 3-to-1, you could get to 6.
could get to 6.
And you'd
that
rip off your D-link.
But would the boat come off, depending on how big the
Well,
boat
that's
is?
all depending on how much the water and surface area and how much it's holding it down.
Yeah.
That's a huge variable.
Because that raft that we had in the previous video, that one was a 10-foot boat. So you're not going to have as much of that volume of water sitting in the boat to crank on.
Yeah.
So I think if we had a larger boat and a nastier raft, it would be a higher volume one and require us to crank on it and pull. It's also interesting to see that the thwart held up so well against that compressive force. Because one of the other techniques is once you pop your D-rings off, you go around the tube
You gotta wrap it.
and then pull it. So now I'm curious
Should we keep pulling? Or
how much is going to take to blow the tube. I want to jump over to some analysis because all of our time in the field and in the lab was super cool, but I want to know what this means for boaters. So let's talk about it. Now, when we look at SOTAR D-rings, and this is one of the D-rings from the test, our measured shear strength of the welded D-ring was 4.7 kilonewtons, or just over 1,000 pounds of force. The break strength of the weld, or basically where the urethane delaminated from the fibers underneath, was 6.05 kilonewtons, or 1,360 pounds. So that's a lot of force right there. And one of the things we learned from this was the shear strength of a D-ring in our test was 26% weaker than the break strength of the welds. So if you are pulling in shear, you're not going to be able to do or put as much force on that before those D-rings pop. And, it got pretty close. So we used a high side raft with this, and I don't have numbers for high side, but with all that said, if we had a similar SOTAR raft, same size, same amount of water coming into the boat, welded D-rings would have been stressed to 73% of their shear strength or 54% of their break strength. So what this means too is, and I'm going to show you some pictures of these D-rings. When we look at the D-ring we pulled in shear, which is this one, you can see a little bit of deformation on the bottom of the D-ring. Now, when we look at that deformation, and when we look at the one we pulled trying to find a general break strength, there is significantly more deformation in the metal. After 4.47 kilonewtons or 1,000 pounds, you're starting to bend metal. And as you bend metal on these things, they're gonna eventually snap and they're gonna eventually break. Now, they didn't snap and they didn't break in our test, which was good. The material broke first, so you're not having shards of metal flying around, but you still are gonna have a D-ring flying through the air if you're pulling with that much force, and you might need that much force. You can see here that the weld broke all the way down to the urethane. So essentially, the urethane peeled off of the internal fibers. That was a really interesting outcome. I really thought that it would break somewhere else, but apparently the urethane bond was stronger than the urethane to nylon bond. I sent this information over to SOTAR, and Jeremiah has been super stoked to carry on this conversation. So huge shout out to him. And it's super cool to see a manufacturer who is willing to put together some old thwarts and slap on some D-rings so we could test it. Awesome that we have that support. So I know how the internet works, and I know this begs a lot of questions. So, I know people are going to say, hey, what about other brands? And, I'd like to say on that I have asked other manufacturers to toss some material and, some D-rings or something like that into the hat and see what they come up with. That being said, some of them were open to it, which was cool. And at the time of publication for this video and recording, I wasn't able to get any samples for those just yet. But I had other manufacturers, and I found this really interesting and a little concerning in my book that some other manufacturers have said they were flat against it. They said they've done independent testing, but they don't want that information in the public domain since it's proprietary. So again, I found that a little bit concerning. If this was the climbing world, we would have information on harnesses and ropes and carabiners and D-links and O-links and all kinds of stuff. Little shackles, everything has a rating because you have to know where it's going to break at. I don't know why a raft manufacturer would be opposed to people knowing about this. The way patent law, especially in the U.S., works, you patent something and then you get to make it. I understand the desire for things to be proprietary, but I feel like there's a safety risk here that we're not addressing. The other manufacturers that have told me, hey, we don't want to do this. We don't want this out in the public domain. I don't know why. They said, hey, we have the best stuff. We've tested it. But I mean, everybody makes that claim. And how do we know? How do we know unless we have ratings and from an independent lab? So I could carry out some of these tests myself, but I'd have to go out and get the product to do it, and buying rafts to just wreck them seems incredibly wasteful. If we had some samples to work with, it'd be a little bit more easy, and I'd prefer to not just buy rafts to destroy them. I feel like that's just pointless. So, all I can say with certainty is I know what you're going to get if you buy a SOTAR, because he gave us these. He wanted us to test them, and he said, hey, I'm going to look at them. I sent it to him at the time of this recording, like a couple days before I recorded this. Send it to him. He said, hey, I'm going to share this with my staff. We want to look at it. We want to analyze it, and we want to see how we can, make better equipment. So hopefully we'll be able to see, some more new D-ring designs from SOTAR. So if you wrap your boat, you can pull that off, and it's not going to cause deformation issues, or it's not going to just tear off the boat. It's an industry standard for every other sport, and I feel like in our sport, we need to have transparency. So that's what I'm calling for with this kind of stuff. Is I'd like to see some transparency, and again, I don't want to just destroy rafts to do it, but if we got the independent testing or from independent labs, that would be awesome. But as with every dive down the rabbit hole, we're left with more questions than answers, so I'm going to leave it here for now. I have a few things on my list for the future, testing larger boats, testing handle strength, and different kinds of unwrapping techniques. So there's a lot of different nuance out there that I want to see happen. We're going to test it. We're going to see what we can do with it. And if there's something that you would like to see us test, please drop a note in the comments below or send me an email. I'll put some contact information on there. But hey, if you stuck with the video this long, thanks so much, and we will see you downstream.